Okay, so normally this would have come later on in the chapter, today's stuff, but I'm like, we just did graphing yesterday of lines, which is graphic systems of equations. Let's get this done right away too, because then we have the graphing all lumped together, and then we got graphing done for this chapter, or for this unit, whatever you want to call it. Okay? So, once again, we are following along on the note sheet for today. And that note sheet is the first part of the packet that you got yesterday. So, we're going to be graphing systems of inequalities. So we're going to have more than one system of inequality, and then we'll actually get to later on, we'll get to going in reverse. Okay? So first step is we are going to treat each individual inequality as if it was an equality, and then we're going to graph that. Okay? So for instance, my first example is y is less than or equal to 3x plus 2, and y is greater than negative x plus 4. So I'm going to treat those individually. So for instance, I'm going to look here first at this one, and I'm going to treat that like y equals 3x plus 2. And I'm going to graph that line, and I'm going to remember back to first semester when we were dealing with just singleton inequalities, that the greater than or equal to, less than or equal to are solid lines, and the greater than and the less than are dashed lines. So you gotta remember back to those two when I'm graphing, but I'm thinking about it like it was an equality. So this one from yesterday, I would start at 2, up 2, then I would have a slope of 3. So from that blue dot, I would go up 3, right 1, or I could go down 3 and left 1. I get that. And then then I look back on the original, because it was a solid line, we're going to put a solid line in there. And again, we're going to go all the way across our graph. So that's where we're sitting at right now. But now, because we are graphing inequalities, we're going to have to shade. So we can test a point. So we talked in first semester about a test point, and if we don't go through the origin, we should use that one. This line didn't go through 0, 0. So we're going to test the origin. I'm going to put it back into my original equation, my original inequality. 0 less than or equal to 3 times 0 plus 2. 3 times 0 is 0, plus 2 is 2, so this inequality is 0 is less than or equal to 2, and that is a true statement. So what I'm going to do, though, instead of shading that whole area, I'm just going to draw some arrows that signify which way we would shade normally on that. But because we don't have, or because we have another one to go yet, we're not going to full on shade just yet. Okay? Okay? So we're sitting with that. So there's where we sit from the other one. Now, we're going to repeat the process, but this time, we're going to graph our other line, or our other inequality. Okay? So I'm going to treat that one like an equality. So I'm going to graph the line y equals negative x plus 4, except I'm going to graph it this time now with a dashed line because it's just a greater than symbol. So negative x plus 4 would be up 4 with a dot. Slope of negative 1 would be down 1 and right 1. Or up 1 and left 1. We would put on there a dashed line. Again, we find a test point. Again, this one doesn't go through the origin, so that's the best one to choose. But you could choose any place as long as it's not on that green dash line. Plugging it back in, 0 is greater than negative 0 plus 4. 0 is greater than positive 4. Is that a true or a false statement? True or false? 0 is greater than 4. That's false. So since my test point was here, I'm going to shade on the opposite side of that line. And then you'd repeat that process if you had a third inequality or a fourth inequality. Okay? You'd repeat that process, getting your error. Okay? The final answer is going to be where all of your arrows are pointing. So we were sitting in this, or we left it with this. So all of my arrows, or in this case, I have the section with 2 arrows in it, is this section. Let's see, creative, multicolored, and giant ones. Is this area. And that will be our top. Okay? So it's just like we did in first semester, except now we're instead of maybe just 1, we're going to do 2, maybe 3, and more. Let's go forth. So what I would like you to do now is on the back side of that note sheet, there are 2 of them. You can do, you guys do this one, number 2, and then we'll do number 3 together because number 3 has an absolute value in it. Okay? Okay? So do number 2 right now. So kind of the first one. thinking equals 2. X equals numbers are vertical lines. In this case, it's solid. There. Test point. Use conversion. Zero greater than or equal to 2. True or false? That's false. And on the right side. Thinking on this one, 4x plus 3y equals 12, so that would be 3y equals negative 4x plus 12, and y equals negative 4 thirds x plus 4. It's going to be a dashed line. Did not go through the origin. So 4 times 0 plus 3 times 0 plus 12. 0 plus 0 is 0. 0 is left 12. That is true. So I would change this side of it. And then lastly, this one, thinking negative 3x plus y equals negative 1. So y then is going to equal positive 3x minus 1. It is a dashed line. I did not go through the origin. In full. Didn't. Negative 3 times 0 plus 0 less than negative 1. That would be 0 less than negative 1. True or false on that. 0 less than negative. That's false. So we would shade that side. So the only spot where all of the arrows are going is here. That's right, great. So first one, we're thinking y equals 2. Y equals 2 is a horizontal line. It will be dashed. It will be 2 up from the origin. Didn't go through the origin, so my test point is the origin. 0 is less than 2, that is true, so I am changing down. Next one, remember, is an absolute value. Absolute values are v-graphs. So the vertex of that graph is going to be at positive 2, comma, negative 1. Because I take this number here, I think oppositely, and then that number goes right into there. Inside parentheses on graphing type things, we think oppositely inside something. In this case, it was inside the absolute value. So, 2 comma negative 1 is right there. Then, my right side slope is going to be positive 2. So from there, on the right side, I would go up 2 and right 1. My left side slope is negative 2. But here's that on the other side. It is going to be a solid line. And my rules for test pointing stay the same. Didn't go through the origin, so I'm going to put the origin back into my equation, or my absolute value inequality. And this time it's going to be in or out. We're going to either shade inside the V or outside of the V. So if I put in 0, 0, that's going to be 0. Greater than or equal to 2 times the absolute value of 0 minus 2 then minus 1. 0 minus 2 is negative 2. Absolute value of negative 2 is positive 2. Positive 2 times 2 is 4. Minus 1 is 3. So I get 0 is greater than or equal to 3. True or false? That's false. So in this particular case, since my test point was on the outside, I would shade then on the inside. That puts the this little B section right there as the only spot. That would be the triangle. Questions, comments, concerns, clarification? Love it. Now that we're experts at this, let's go in reverse of what we just did. Okay? So now I'm going to give you the picture. I want you to give me the system of inequality. Okay? Yes, ma'am. In the first one, yes, in a system, the answer to your question is yes. But this first one is technically not a system because we're just using it to go in reverse. Yep, just getting you to think about how to go in reverse. Find a system that's more than one. Correct. Yep. Okay. So the first thing that you would have to do is you would have to figure out what line you're dealing with. And you would do this individually for each line in the system. If it were a system, this one is only one. Okay? So I would say that this point right here is my y-intercept, and it is 1, 2, 3 up. So that would have a b value of 3. I would also say that from any point on that graph, it appears that we are going up 1 and right 1 at all times, or we're going up 3 and right 3. Rise over run, so the up would be 3, the run would be 3. 3 divided by 3 is 1, or 1 divided by 1 is 1. So that would tell me my slope is 1. So the equation of this line is y equals x plus 3. Yes? Okay. Now, because they're shading, now I've got to figure out the inequality that goes along with that. Well, I know that it's going to be y and then x plus 3. I just have to fill in the inequality. So again, we look at a test point. So if I test the origin, if I plug in the origin into y and x plus 3, that's going to be 0. 0 plus 3 is going to be 3. I need that, so I need something with 0 and 3 to be a true statement, because it's shaded on that side. So my alligator would have to eat the bigger number for it to be true. So this becomes a less than or equal to system. Okay? So we're basically doing the same thing, except now we're having to come up with the equations on the line, given the picture. Okay? Let's try another one. So it appears this one right here is once again 1, 2, 3. It's got a y-intercept of 3. I would say that it's got a slope of 1. Up 1, right 1, up 1, right 1, up the whole way through. Would you agree? So that line would then again be y equals x plus 3. It's the same thing we just had. In fact, it is the exact same thing. Okay? This line right here appears to be vertical. Correct? So that would be an x equals 1, 2, 3. Equals 3. Yeah. Okay. But love it. Okay. So my system is going to be y something x plus 3 and x something 3. Neither one of them went through the origin. So if I plug in 0 into y equals x plus 3, I get the same thing that we just had before. So this would be that. If I plug in 0 here, 0, 0 plus 3. In order for it to be true, it's got to look like that. Great. Now with x, if I plug in the origin again, because I didn't go through it, I have 0 and 3. I want that to be true. It's a dashed line though, so it's only going to look like that. You want true statements. Oh, excuse me. Yeah. No, I don't want a true statement there. Tap the brakes. I was shading on the wrong side. I want a false statement there. Whoa, Roland. True statement would have been shading the other way. I want a false statement here. Okay. We want to go that way. Got ahead of it. Because of the shade, because we're not shading on the test point. Okay. Good. So you now have enough information to complete this week's homework, which is the second page of the packet that you got yesterday. Yeah. Okay. Good to go.